Good morning. My name is Tansel Salaklar. I am the Federal Program Manager for Advanced Methods for Manufacturing, Nuclear Science User Facilities, and Transformational Challenge Reactor Programs. We will be covering 4 work scopes today. I will start with NEET-1, which is AMM. Then NSUF-1.2, irradiation testing of materials. And then Dr. Rory Kennedy will present a new initiative and a new work scope this year under NSUF-1.3, which is nuclear materials discovery and qualification. And then finally, I will talk about another new work scope for this year, for transformational challenge reactor. So I will start with advanced methods for manufacturing, AMM in short. AMM program, which was initiated in 2012, is one program element of nuclear energy enabling cross-cutting technology development, whose focus is to improve the methods by which nuclear equipment, components, and plants are manufactured, fabricated, and assembled by utilizing state-of-the-art methods. The overall purpose of the AMM cross-cutting program is to accelerate innovations that reduce the cost and schedule of constructing new nuclear plants and make fabrication of nuclear power plant components faster, cheaper, and more reliable. So NEET-1 technical focus area is for advanced methods for manufacturing. Every year, we review and revise our work scope with consideration of our current projects and to have a good distribution on the types of the projects. This year, we decided to focus on 2 main areas, factory and field fabrication techniques, specifically for surface modification and cladding techniques and modular factory and field fabrication, and quality control techniques and qualification methodologies. Advanced fabrication and manufacturing methods will require advances in surface modification and cladding techniques. Cladding and surface modification techniques in current nuclear components are typically applied through some form of welding, a process that melts one material into another. This causes unique alloys at the interface. These material differences are the cause of many surface and subsurface flaws. Avoiding melting, by which solid state, cold spray, or other bonding processes can eliminate the welded clad problems. So we are interested in these kind of techniques. We are also interested in modular fabrication, which are factory built, transportable, capable of precise placement, engineered to their function in their environment, and easily mated to a single entity. The second focus area we are interested in this year is excuse me, quality control techniques and qualification methodologies. There is a significant impediment to the use of AMM techniques. There is no established criteria for the qualification of safety-related nuclear components produced by using these techniques. So one of the major challenges to be addressed in AMM methods are lack of specifications and standards. All the other agencies who are currently pursuing AMM technologies have established roadmaps for the certification and approval of AM components within their jurisdictions. These include NASA, DOD, FAA, and the branches of the military. So This year, we are seeking proposals which can develop a qualification method for safety-related components and acceptance criteria and inspection methods which can be accepted by standard organizations such as ASME and ASTM. So I'm going to move on to NSUF-1.2. This work scope is for irradiation testing of materials produced by innovative manufacturing techniques. All pre-irradiation characterization activities should be complete before you apply for this funding. This work scope is open to universities, laboratories, and to industry. Coupling to modeling mechanisms to predict performance metrics and enhancements is encouraged. Please note that this funding does not support new research and development activities. So, in summary, we are seeking proposals to develop techniques or components to decrease the cost of manufacturing and fabrication of nuclear power plants or improve the cost and schedule of construction times, specifically for the areas I previously mentioned. We are also seeking proposals to develop qualification method for safety-related nuclear components and acceptance criteria and inspection methods which can be accepted by standard organizations. So this is my contact information. Our latest 2019 AMM award summaries will be posted on our website shortly. We strongly recommend that the potential applicant should review the work we have supported to date in order to gain a better understanding of what is of interest and to ensure to avoid duplication. So this is end of my two work scope presentation. If you have any questions, I will try to answer. If for some reason I can't, please email me my contact information on this slide, and I will get back to you as soon as I can after consulting with my technical experts. Thank you.
Okay, we're going to bring Rory Kennedy on the line to present NSUF 1.3. Rory, can you hear us?
Yes, I can.
Okay,
Ready
great.
to go?
We can hear you too.
Okay, thanks. So I'm Rory Kennedy. I'm the Director of the Nuclear Science User Facilities, the NSUF, and I'll be giving this presentation on this new initiative coming out of the NSUF. So for DOE's goals to aid industry and to accelerate innovation, the advancement of nuclear, for example, the Gateway for Accelerated Innovation in Nuclear, the GAIN initiative that was going on, or that was started a few years back, is a good example of that. DOE once again, to try and aid industry, is starting a new initiative called the Nuclear Materials Discovery and Qualification Initiative in order to address bringing new materials to accelerate the discovery and the qualification of new materials to satisfy the needs of the nuclear industry. Basically, this is following or we're applying the tools and the philosophy for the Materials Genome Initiative, which started generally a number of years back, 10 or 12 years ago, to bring materials to market faster and at a lower cost, and to bring those tools together. And so what we're doing is applying the materials design concept to nuclear, which is something new. We see that there's some through different through different work scopes that are being that have been and will be presented for accelerated testing of that, and a lot of that does fall into this realm in order to try and create tools that will enable rapid testing of material properties for radioactive materials, which is our unique difficulty in the area of nuclear. So this is a special work scope because typically NSUF does not set up its own work scope for a particular area and supply the R&D fundings. But that is what we will be doing on this one, and only this one. So typically for the NSUF-1s and the other program supplies it, the R&D fundings for the PI, but in this case, NSUF will be supporting that. This will be, and our review system, just to mention this, will be a little bit, you might say, a little bit more lenient on the readiness review. Before we were very careful about that you had to have your materials, and Greg and Dan Ogden mentioned this, pretty much ready to go before we go, because we're interested in the irradiation effects, doing irradiation studies. But in this case, we'll be a bit more lenient on that because this is just initiating this program and offering part of this program to a general competition through this process, the CINR, in order that if you can develop some fabrication method with your R&D dollars, we'll go forward with that. So getting back to what we're interested in this work scope and applying the materials design concept through, is that we use what's called, and if you check up on the Materials Genome Initiative and associated work that's been going on and has been very successful in a number of other industries, if we apply the combinatorial and high throughput methodology that integrates combinatorial materials fabrication so that you fabricate quickly a large number of different, say, compositions or different processes on a single composition or so, and then apply rapid throughput, high throughput characterization techniques. So we have great interest, and again, as I mentioned in other work scopes, these are mentioned also, property testing on radioactive materials, and this can include automation and also some robotics. We're interested in technique development, new technique development, again, or adapting techniques to radioactive environments, whether hot cells or shielded environments. And one of the important thing is there's a great push right now using FIB to make smaller samples in order to reduce the radioactivity and do the testing. So it would be rapid high throughput characterization on smaller samples. But what we need to understand better is that the nano to micro to bulk property relationship. So if we measure at the nano, we understand what the property relationship will be in the bulk. Material modeling is quite important to us so the multi-physics, multi-dimensional or multi-scale modeling associated, and very important part of the materials design component is the computational, the data analytics, and this can include machine learning. This is coming very much to the fore now in a lot of areas for material design, for machine learning and artificial intelligence. So this is a very exciting area that we think nuclear should be pushing forward with. As far as the areas of nuclear, the fuels and materials, what we think this can be applied to, and again, for NSUF, we're linking about all the way from fabrication all the way through irradiation and post-irradiation examination. Core materials, structural materials, including cladding, fuels, any of the advanced fuels types, whether metallic, ceramic, or so, or sensor materials. We think about coatings, the push in accident-tolerant fuel with coatings, and of course corrosion. And that's just a few. If others have any other ideas to go with this, that would be fine. So again, this is a sort of a pilot project for us for DOE with the NSUF to see if we can launch an initiative like this through NSUF, because it's directly related to our goals with accelerating and bringing innovation as quickly as possible out to the nuclear community, bring it to market, and we look forward to working with everyone and industry also. This work scope is open to academia, government labs, national laboratories, industry, as well as small business. And so with that, I will go to the next slide. I think we have the contacts on there. Can I do that? Can we move the slide forward?
I think there's only one slide, Rory.
Oh, there isn't? I thought we had a contact slide afterwards. Anyway, I can be contacted. I'm on the NSUF. Oh, there we are. So Tanzel is the program manager. I'm the technical point of contact for this, for the CINR, and there are our contact information, and we'll take any questions right now if you have.
Okay. We'll start taking questions on the NEET-1, NSUF 1.2, and NSUF 1.3 areas. Please do submit those questions in the question box in the GoToWebinar meeting application. Tancel will start with NSUF 1.2. Does solid state diffusion bonding, is that covered in the call?
Yes, if it is ready for irradiation, the material, definitely.
In NSUF 1.3, is there research funding associated with that call?
Yes, and it's up to 500K over a period of 3 years.
For the surface modification, are you mainly interested in corrosion protection?
That's part of it, yes. Wear-resistant applications for components, anything applicable, we will accept that.
I noticed concrete was mentioned in your presentation. What other materials are of interest?
Well, that's the only one I can think of right now, but if you can come up with anything else, please do so. That's certainly the interest.
This question is for NSUF 1.3. What TRL level for technique development is expected?
Oh, all TRL levels.
Also for NSUF 1.3, does the material have to be produced through high throughput fabrication methods?
No, not necessarily. It'll all depend. I mean, we'll have to look on a case-by-case basis when we review. But the principle is to, again, is to accelerate the fabrication characterization, ultimately the qualification of the materials. So, as a strict answer, no, it doesn't have to be.
Rory, an additional question for NSUF 1.3. Does it require the utilization of user facilities?
No, it does not. Your R&D dollars, you can spend them wherever you would care to spend them. But NSUF facilities are available for the proposer.
So to be clear, Rory, you are looking for a user facility component in NSUF 1.3 though, correct?
Yes.
An additional question for NSUF 1.3. Must proposals include fabrication, characterization, modeling, and analytics? Or is a focus of just one or two of these areas of interest?
If you focus on one or two of these areas, that's fine.
Okay, there's a similar question to the previous question about high throughput. Does NSUF 1.3 allow high throughput calculations followed by machine learning and verification by experiments within the scope?
Can you repeat that one, please?
Does NSUF 1.3 allow high throughput calculations followed by machine learning and verification by experiments?
Yes.
In NSUF 1.3, there's a request for a clarification. The question is, do we understand this correctly? This does not require use of an NSUF facility. And is the funding for this also $1 million for 3 years?
No. The funding is not $1 million for 3 years. It's $500K for 3 years for the R&D dollars. And yes, we want to have you use NSUF capabilities for this. This is a NSUF R&D plus NSUF access. So yes, we would want to have access to NSUF capabilities, or we want to have the proposal to use NSUF capabilities. Not for everything, but some of NSUF capabilities to be used. And that could be high performance computing capabilities here at INL, and or any of the other instrumentation that we have around the complex, around the U.S.
For NSUF 1.3, does the scope require neutron irradiation, or will ion irradiation be sufficient for concept demonstration?
That will be fine. Ion irradiation will be all right.
Also for NSUF 1.3, since R&D is funded by NSUF, does PI ship or co-PI ship count toward one's limit of 3 lead PI, 3 co-PI NUP projects? And the NUP office will answer this question. The answer here will be yes. And the reason for that is it's an NSUF-1 scope, meaning the lead PI will be conducting research and development activities. For NEET-1, are there any techniques involving the melting of materials, or are those excluded?
Any techniques, we are open.
Would you be interested in in situ HT measurements of thermal expansions of ceramics in 3D?
Not this year.
In one of the presentations, it said different material characteristics are required for various reactor concepts, fast versus thermal. Can you elaborate more on that? Roy, I think that question is directed at you.
Yeah, well, I never made that statement, but it is true. I mean, there's different, for example, in cladding, I can give you that with under fast flux that you have swelling in the austenitic type steels for the cladding, and where you have reduced swelling in ferritic martensitic. So you have different fuel behavior under fast versus thermal, where the temperatures can be different, and the thermal gradients are different within the fuel or the fuel pin. So there's a couple examples of difference in the thermal versus fast and the material or fuel types.
For NSUF 1.3, is a separate application for NSUF access needed?
Versus the R&D part of it? No, it's one application.
Yeah.
It's one application.
Yeah, so to clarify, it's one application. There is an expansion of the page limit when you get to the full application, up to 15 pages, so you can include additional details about the NSUF scope. So you will need to submit a letter of intent that includes both the R&D and the NSUF descriptions as you go through the process. For NEET-1 and 1.1, what surface modification techniques are especially sought? Are you interested in wear resistance techniques, coatings, or fatigue?
All.
Also for NEET-1, Are you interested in geopolymer ceramic composites, which are made from like cements?
I have not thought about that, but yes, why not?
So they said like cements, but materials that can reach 1200 C.
Yes.
Okay. For NEET 1.2, are you looking for new qualification inspection technique development or use of existing inspection standards?
NEET 1.2, you mean NSUF-1?
It would probably be NSUF 1.2.
I'm sorry, can you repeat that?
Are you looking for new qualification / inspection technique development or use of existing inspection standards?
There is no inspection standards for nuclear for this specific the techniques, advanced methods, any advanced methods for manufacturing. So we are interested any inspection methods and methodologies or qualification or standards, we are definitely interested in.
Okay, Rory, there's a clarification on the fast versus thermal reactor question. The clarification is, what is the focus? Is it on fast or is it on thermal reactors?
For 1.3? I mean, it's
I'm assuming
it's
so. It's
general.
not clarified.
I don't know where this question is directed towards. If it's 1.3, there is no thermal or fast reactor directive for this, for the advancement of the materials. You can pick your reactor, pick the material, and the environment that you're working in. I don't know about. I don't believe Tonzel with the advanced manufacturing has a directive for thermal versus fast, but
I did not either.
For 1.3, is the application process like NSUF 1.2, or is it just one pre-application needed by September 24th? NSUF 1.3 is an NSUF work scope, meaning it requires an LOI and follows the process of other NSUF work scopes in the past. If you're unfamiliar with that process, please do. You can refer to a past FOA currently, or you can look at the new FOA when it's released in the next few weeks. For NEET 1.1, I'm assuming just NEET 1.
Yeah.
Are you interested in surface modification with novel material or improvements made in current materials with advanced manufacturing?
Both.
Okay, we are going to put a pause on questions at this point, and we are going to go over the transformational challenge reactor scopes that Tansel will present.
Okay, our next topic is transformational challenge reactor. Transformational challenge reactor is a new FY19 initiative and provides a revolutionary platform to demonstrate the ability to reduce the deployment costs and timelines for nuclear energy systems. The TCR program enhances the development of breakthrough technologies that provide the ability to manufacture small or micro advanced reactor components using additive manufacturing techniques. A central goal of the TCR program is to demonstrate the ability to exploit advanced manufacturing techniques and digital predictive analysis capabilities to deliver a new approach to nuclear design and qualification for advanced reactor technologies. It will combine advanced manufacturing with materials and computational sciences for nuclear applications. Yeah. So for the draft FOA, we said this topic specific NE-3 TBD. So we are currently working on it. The work scope is being developed, and after being reviewed and approved, we will publish it in the final FOA, which is expected in the next couple of weeks. But I'm gonna give you a general idea what highly likely we are gonna ask for. So this work scope will be seeking proposals to provide validation of the approaches taken by the TCR program on key areas, including application of quality assurance to artificial intelligence, automation of reactor control systems, and the expected performance of the nuclear core design. So at this point, I can only tell you this much about the specifics of the work scope, but please read the final FOA. We will publish it, and then this work scope will be open to universities only, by the way. And I am the federal program manager for this program, and Sherry Buchanan is our technical point of contact. She's also the program director for this specific program from Oak Ridge National Laboratory, and she's with me today. We cannot answer your specific questions for the work scope at this point, but if you have any general or generic questions for TCR, we'll be happy to answer.
Okay, we have the question box open for additional questions for TCR. First question is, will thermal hydraulic challenges be of interest?
Well, the work scope is not being finalized. It is under review, and I cannot tell you the specific topics at this point. Please wait a couple of weeks and then email me, or Sherry will be more than glad to answer you.
What labs are involved in TCR?
TCR is Oak Ridge National Laboratory-led program and with partnership of Idaho National Lab and Argonne National Lab.
TCR is a gas-cooled reactor, so is this study only relevant to gas-cooled reactors?
Study of, I do not know the question. If it is about the core performance, we will publish our work scope in detail. And yes, it's a helium-cooled gas reactor.
Moving back to NEET-1, qualification and quality control of advanced manufacturing process samples. Okay, hang on, let me reword the question. Are you looking for inspection of cladded structures, or does this relate to all nuclear structures and materials? I believe this is in regards to the qualification and quality control area.
We are looking for any qualification or methodologies regarding any advanced methods in manufacturing, not just for cladding.
We'll hang on for about 30 more seconds with Tencel and Sherry for any additional TCR questions or any questions over that are on topics over the past half hour. Looks like we don't have any additional questions. We are going to be taking a lunch break here on the East Coast. So we will return at 1:30 Eastern time. Brad Williams will be discussing the mission supporting Grand Challenge Work Scope at MS NE-3. Thanks, everyone.